ये सब सिर्फ अफवाह भाई, सिर्फ अफवाह। 6,000 नहीं भाई, महंगा हो गया।
Good morning, everyone.
गुड मॉर्निंग।
बोली लगा रहा है ये बंदा, देख लो।
How are you all this week? Am I audible?
Yes, sir.
Oh, sleeping mode. So I received a few assignments, but not from everyone. I would request to share the assignments as app. So before I start with today's session, do you have any questions, please?
No, Anupama. Not from my end.
From anyone else? While doing the assignment or while going through the notes, I've submitted lab 1, we'll submit lab 2 and lab 3 this week, okay? So MD, while you're talking, you just need to be on mute, okay? So initially you were not on mute. Okay, so please take care of that. Any other questions, please? Okay. So how many of you are from networking background? No one? Okay. So this week, we would be discussing about the VPC, which is a networking service. And we will cover the database services. If time permits, we will also complete Route 53 or any other small services related, we will cover them. Okay, that is this week's agenda. So today explicitly we'll talk about VPC. Tomorrow we will see the VPC slides, and also the databases will be covered tomorrow itself. Yeah. So let me share my screen. But before that, just give me a moment. Let me open a few other tools to explain about VPC. Are you able to see my screen? Yes. Yes. Okay, cool.
Yes, we can see.
I'm sorry?
Screen is visible.
Visible. Okay. Amazon VPC. VPC stands for Virtual Private Cloud. Okay. So when you create an AWS account, AWS creates a VPC in each and every region. And that VPC is called a default VPC. Okay. Now let's see how to create a custom VPC in the cloud, in AWS cloud. Okay. Now, first of all, VPC is like a network. A network is a collection of IP addresses or a collection of machines connected together where they can exchange data privately. Now, for example, if you're working in any organization, the laptop or the desktop which is given to you will be in an organization network. Okay. The same way, in cloud, we can create our own network with the help of VPC. Do you hear any background noise? Just let me know. Okay. Now, in AWS, in North Virginia region, there we create a VPC. Means VPC is region specific. VPC would be created in a region. It spans all availability zones in a region. Okay. So can I have a VPC sharing two regions? No. VPC is region specific. Okay. Now, when I say creating a VPC, I'm talking about creating a network. Now, when you create a network, you need to provide a network ID. Like any other organization, even AWS follows some standards, which is RFC 918 standards. You can explore what exactly is this in internet. Okay. AWS, like any other organization, even AWS follows RFC 918 standards. In order to create a network ID, or we can also call it as CIDR, classless interdomain range or routing, CIDR, or network ID. So for this VPC, we can actually go for any one of these CIDRs. Okay. Now let's understand what exactly are these. So 10.0.0.0 /16. Now, if I exclude this /16 a bit, for a bit, if you see this, this looks like an IP address, isn't it? Something like 17.2.3. Some 5. This looks like an IP address, right? And this IP address is an IPv4 address, basically. It's a 4th version of the Internet Protocol. And this IPv4 address is of a 32-bit long. This IP address is divided into 4 octets separated by dots or periods. Okay. First octet, second, third, fourth. 4 octets. So if you see, this is an octet. This is an octet. An octet is of 8 bits. You have 4 octets, 8 fours, 32-bit. So an IPv4 address is a 32-bit long. Now when you say bit, it could be either 0 or 1. Right? Now an octet is of 8 bits. Now if you need to represent the octet in binary, it would be from 8 zeros to 8 ones. Okay, because octet is of 8 bits, right? So the value of an octet can range from all zeros to all ones. Now, if you convert this into decimal, basically the values which we read usually. Now, when we say all zeros, the value in decimal is 0 itself, because the value of all zeros is 0. When we add up all zeros, it is just 0. And when we say all ones, in decimal, the value of 1 in each position represent a value. Guys, do you hear any background noise?
No.
Perfect.
No.
Cool then. Please concentrate here. And let me know if you're hearing any background noise. I'll try to minimize it. So the 1 in each position in decimal has a value in it. Okay. So the rightmost one value in decimal is 2 power 0, which is 1. And then it's 2 power 1, which is 2. And then 2 square, which is 4. And then 2 cube. So if you observe here, it is just a multiplication of 2 from the right number. So 1 multiplied by 2, and then 2 into 2, 4 twos, 8 twos. (128). So 2 power 7, 6, 5, 4, 3, 2, 1, 0. So in decimal, each value, each one has a value in it. Now, if we add up all these numbers, the value would be 255. Okay. So the range of an octet can go from 0 to 255. You see any IPv4 address in the world, you will never have a value below 0 beyond 255 IPv4. Okay? Clear so far?
Yes.
Now, Now let's go back to our actual CIDR. Now we learned that this is like an IPv4 divided into 4 octets. Each octet carries 8 bits, right? Now, when I say /16, it represents the first 16 bits. Eight bits, 8 bits, 8 bits, 8 bits, right? It represents the first 16 bits as what? As network prefix. As network prefix means all the machines or all the IP addresses in this network will start with 10.0. It is prefix. Okay. So it represents the network. When once you see an IP address, you would know which network it is. It represents the network prefix. Sorry, it represents the network. Okay. Now the remaining bits, whatever the remaining bits you have, those are for hosting. Where this octet can go from 0 to 255, and even this can go from 0 to 255, because we learned that this octet, okay, can go from 0 to 255. Whereas the first 2 octets is a network prefix. It is fixed. Now, if you can write the combinations of IP addresses we get if we give this network ID, 10.0 is fixed. It will not change throughout the network. Now, if you write the combinations here, 0.0, 0.1, 0.2, so and so forth, 0.255. 10.0.1.0, 1.1, 1.2, so and so forth, 1.255. Ten dot 0.2.0, 2.1, 2.2, so and so forth, 2.255. So 0, 1, 2, so and so forth, 10.0.255.0, 255.1, 255.2, 255.255. So the 10.0 is fixed throughout the network, where these 2 octets can go from 0 to 255. Understood how we got these IP addresses? Yes.
Yes.
Yes. What is
Now,
16? Right.
sorry, come again.
What is this /16?
That is a range standards. The /16 represents the 16 bits, the first 16 bits.
First 16 means 10.0 is first 16 bit, right? In this case.
Eight.
Yes. It
Mm.
contains 8 plus 8, no?
Mm-hmm.
So, if you see this range, and within that, if you take this particular part, one part. Now, when I say 0 to 255, how many IP address I'm getting? When I say 0 to 255, only this part, how many IP address I'm getting?
256 addresses. That will include one.
And how many parts I have like that? 0, 1, 2, again 255. So again 0 to 255. How many parts I have like that?
55 parts.
Including 0, we have
Oh,
256 parts.
yes, yes.
So where we would be getting around 65,000 plus IP addresses if we create a network with this particular CIDR. So if I create a VPC with this CIDR, I would be getting around 65,000 plus. Now, the number of IP addresses would remain same if you go for this range or this range, because if you go for this range 172.16.0.0/16, again the /16 represents the first two octets. 170.16 would be the network prefix, and you have two octets for hosting. Even in here, 192.168 would be the network prefix, and you have two other octets for hosting. Okay, so whether you go for any of these ranges, you would be getting 65,000 plus IP addresses. Now, we are talking about the /16, right? You need not go for /16 all the time. You can go from /16 to 28, like 16, 17, 18, 19, 20 till 28. Okay. Now, for example, if I go for /28, the 28 represents the first 28 bits. Ashish, if you couldn't recollect, when we say 16, it represents the first 16 bits. Okay. So these are octets, right? These are of 32 bit. This is an IPv4 of 32 bit long. Now, when we say 28, the first 28 bits would be for network prefix. So 8 plus 8 plus 8, which makes 24, and you would take 4 bits from the fourth octet also out of 8. Okay, so half of it, almost half of the octet would be of network prefix. So 10.0.0. Half of the octet would be of network prefix, and you'll have only 4 bits for hosting. Where you will be getting only 16 IP addresses if you give this range. Okay, so the more the number, the more the network prefix, the less the IP addresses. So when you are creating a network ID, depending upon the number of IP addresses you wanted, for example, if it is a small startup, they don't need 65,000 plus machines. They might be needing only few hundreds. Okay, or tens. So depending upon their requirement, they can go from /16 to 28.
Is there any advantage here increasing the range?
In future, if you want to expand, the network ID will never become a bottleneck. So if you go for /16 straight away, you will be getting 65,000 plus IP addresses. You might be needing, you might need only few. Okay, but in future, if you want to expand your network, if you want to expand your business and you need more IP addresses, you will get it anyways. But if you go for /28, you get only 16 IP addresses. For example, I need only 3 or 4. So I created a small network. Now later, if I want to expand, no, this network will become a bottleneck for me, isn't it? So whether you go for 16 or 28, there will be no cost in creating a VPC anyways. So AWS recommends to go for a bigger one, but AWS still supports a range according to the requirement. Any questions?
So this ranges, the CIDR ranges like 10, 172, these are fixed, right? We have to use from this one only.
That's right. These are the standards.
Mhm.
Even any organization uses this standard.
Got it.
So going with 28 range, we cannot scale it is what you're saying, right? So going with the lesser range is always advantageous. Right?
Correct. Correct. So
Okay.
when we say 28, if you wanted to use only few forever, that's fine. You can go for it. But maybe in future, if you need to expand, the network ID, once it is created, it cannot be changed.
Mhm.
You cannot increase it. Okay. Now, once we create a network, in order to have the machines in that network, we have to have subnetworks. Okay. So let me create this will be more clear if we learn subnetting. Definitely. So that is the reason I asked if you are from networking background. Don't worry, I'll completely simplify it. Okay, whatever it is required for VPC, I will teach that. If you wanted to go for networking background, or if you are looking for any networking domain, then yes, learn subnetting and all. Okay, we have a lot of tools in internet where you can automate the subnetting process. Not to worry about it. But ultimately, if you understand the basic concept, you should be fine. So let me create two subnets. I'll name it as public subnet. I'll justify this term little later. And another subnet, I'll call it as a private subnet. Okay. Now, when you are creating a subnetwork, you will be having a subnetwork ID also. Okay. Now, if I have 100 IP addresses and I have 100 machines, and I have 4 departments. Now, instead of giving these 100 IP addresses to all 4 departments, what I can do is I can create 4 subnets, 25 each. Okay. And I can assign these 25 machines to each department. I mean to say each 25 to each department. Okay. Now in this way, I can control the permissions for each department. Maybe the department 1 needs a specific permissions, which the other departments don't need it. And vice versa, obviously, like so and so forth. Okay. Now, whatever the permissions which I need for the department 1, I can assign it separate. Same with other departments as well. Okay. So instead of going for a whole network, if we create into multiple sub networks, we can manage it well. So what I'm doing, I created 2 subnets. So the first subnet CIDR is 10.0.1.0/24. Now, when I say /24, this is a sub network. It's not the main network. Okay. Now, 10.0 is already a network prefix. Okay. And the third octet is a subnet ID, because we say 24, 8, 8, 16, which is already a network prefix. And there is a third octet because we are saying 24, 8 plus 8 plus 8, 24. So out of the remaining octet is basically the subnet ID. Out of 24, the first 16 bits is already network prefix. And the remaining bits is for subnetwork ID, is a subnet ID. So combinedly, we call it as subnetwork prefix. And we have the remaining bits for hosting, or the fourth octet for hosting, where we can go from 0 to 255. That means all the IP addresses in this particular subnet with this range, okay, will start with 10.0.1. Okay. Now, if we can write the combinations of IP addresses, 10.0.1 is a fix, basically a subnetwork prefix, right? And the fourth octet can go from 0 to 255. Yeah. Now, if you see this, you see this part, 10.0.1.0, 1.1, 2, so and so forth, 1.255. So this is not a subnet. Yeah. So subnet is a logical partitioning of your main network. Now I have divided this part and I made it as a subnet. So this range is what? 10.0.1.0/24. The same way with another subnet. What is the range of subnet to? 10.0.2.0/24. Again, 10.0 is network prefix plus 2 is a subnetwork prefix. Same as this, but here you have 1, here you have 2, that's it. And this is for hosting, where you can go from 0 to 255. Now, if you can write the combinations, 10.0.2.0, 2.1, 2.2, 2.3, so and so forth, 2.255. Again, this is this range, right? This is the subnet 2. 10.0.2.0.1.2, so and so forth, 255. So like that, we can create multiple sub networks. Now we can, even the subnet, you need not use /24 all the time, okay? I hope I'm not confusing. Even the subnet range can go from /16 to 28. You need not go for 24 all the time. I just simplified it, oversimplified, basically for the convenience. Okay? So even the subnet range can go from /16 to 28. Okay? We just took 24. Now, when you say /24 and then you have one octet for hosting where you can go from 0 to 255, how many IP addresses we are getting it?
256.
256. Now, in each and every subnet which we create, in each and every subnet, the first 4 IP addresses and the last one, Explicitly it says what IP address also. So in each and every subnet, the first 4 IP addresses and the last one are the reserved IP addresses. AWS will be reserving it. For some reason, we will see that in the slides. But for now, just understand that in each and every subnet, okay, not in just one subnet. Okay. So there will be 5 reserved IP addresses. Okay. So even though you could see we have 256 IP addresses, but in actual, how many we can use it? 251. Okay. Even for the subnet 2, we get 0 to 255, 256 IP addresses, 5 reserved, where you can use only 251.
Aren't
So
there 4 plus 4, 8? First 4 and last 4.
first 4 and last 1.
Last
It is
one.
5. The first 4 and last 1, 5. Okay. Understood so far? Any questions? Okay. Now, once we create subnets, and if we have machines in that subnets, if they need internet access, so we have to have internet access for the VPC. So in order to have the internet access for the VPC, we have to have an internet gateway. We need to create an internet gateway and attach it to the VPC to get the internet access for the VPC. Now, just by having an internet gateway attached to the VPC doesn't mean all the instances in the subnets will be able to access to the internet. No, it doesn't mean that way. It has to be explicitly route using the route tables. Okay. So coming to the justification of these terms now, why I'm calling one as public, other one as private. If a subnet is associated, if a subnet is associated with a route table, which has internet gateway as a route, then this subnet will become a public subnet. The same way, if a subnet is associated with a route table, which doesn't have internet gateway as a route, then this subnet will become a private subnet. Okay. Now, because this subnet is associated with the route table, I name this as a public route table as a naming convention. And this I can call it as a private route table. Okay. Now, if a subnet is associated with a route table which has internet gateway as a route, we call it as a public subnet, correct? So that the EC2 instances the EC2 instances in this subnet will be able to access to the internet because I created a path. So by default, it will have a private IP address. Okay. Because it is accessing from internet, we will enable the public IP address. But the EC2 instance in the private subnet, because it's a private subnet, it doesn't have internet access. The EC2 instance will not be able to access to the internet. It will have only the private IP address. We will not enable the public IP address. So the meaning of public subnet means the EC2 instances in that subnet will be able to reach the internet. When we say the private subnet, the EC2 instances will not be able to access the internet. So in a exam, in AWS certification exam, they would say it as a public subnet or private subnet. So you need to understand that, okay, when you say public subnet, the subnet route table is having internet gateway as a route. The instances can access to the internet. If they say private subnet, it doesn't have a route. Now let's understand why we need to go for this kind of setup. Why a subnet should be public, why a subnet should be private, etc. Let me give an example. You take a Facebook application. Facebook application will be on a server. And the application can be accessible from internet. They just give facebook.com. And application will have a database. And you'll have a DB server for that. Okay. And obviously, in the application logic, we need to give a DB endpoint so that whenever the users are accessing some data, the application server will hit the DB server and the DB server will respond to the application server to respond to the user. Okay. Now the user is having access to the application server. But does the user is having access to the database server directly?
No.
No, that's not the case. Because it is not just user data, particular user data. Everyone's data would be there in the database. So the user using their credentials according to the permissions, he or she can access the relevant data according to the account from the database. But the user will not have access directly to the database. I'm just trying to replicate that. So you can have your application here and you can have your database here ideally. Because the EC2 instance is having access to the internet, from internet they can access the application. Because these two EC2 instances are in the same network, they can communicate with each other using a private IP address. But from the internet, the user cannot reach to the database. because there is no route of the internet gateway in the routing. Okay, ideally, if you are going for a application and database, you can create this kind of architecture. Okay, any questions so far?
Not yet.
No, all good.
Okay, now, folks, just give me a moment. My battery is dying. Just 2 minutes, please. So, my God. Yeah. Now let's assume you have an application here. Okay. You have an application here and you have a database. Now the user accessing the application and then from internet and then privately they're accessing the data from the database server. Now this EC2 instance clearly doesn't have internet access, right? For security reason. Now what if I want the database to update or upgrade to a latest version? What is required if I want to update or upgrade my database? Hello?
We can connect to subnet 1.
Which one?
Which is connected with internet gateway.
Okay, how to connect?
Yeah, I'm just guessing it only.
if we connect to subnet 1 or public subnet, how this EC2 instance will get internet access?
Then if we don't have internet, how are we going to create EC2?
We can, of course, we can create an EC2 instance, right? The EC2 instance is not having internet access, not us. We should be having an internet access to create all the network and the components. You're confusing.
I am confused. So is there any kind of this Route 53 services like that which can do this, which you told earlier?
Route 53 is used for creating domain names. That's out of the topic for now.
My guesses are over now.
Folks, if I want to update or upgrade my database, what is required first of all?
Network
Internet.
connection.
Network.
Connection to the database.
Okay.
I need
So
internet. Yeah.
exactly, we need internet access. We need internet access in order to update or upgrade a database server. Okay. Now to get the internet access for a DB server, we can go for NAT. So the NAT has to have a route in the route table, because the NAT is created in the public subnet. It will have a public IP address so that whenever the EC2 instance is making a request to the internet, the private IP address of the instance will translate into the public IP address of the NAT to go to the internet. So while instance is making a request, the private IP address of the instance will translate into the public IP address of the NAT to go to the internet, like this. To go to the internet. Now, while the internet is responding, the public IP address of the NAT will translate into the private IP address of the instance to reach the instance. Because it is translating the network address from private to public while going and public to private while coming, it's called network address translator or translation. Okay. So using the NAT, the EC2 instances can reach the internet. Now then you can ask me, now this EC2 instance is able to access to internet through internet gateway. Now I'm saying this EC2 instance also can access the internet through NAT, but even this instance also can access the internet. So if both the EC2 instances are able to access the internet, then what is the difference between two? Why can't we simply have an internet gateway? Why were you going for NAT? Let's understand. So in simple terms, let's understand the difference between NAT and internet gateway. So I have an EC2 instance. This is internet. Through internet. internet gateway. Okay. The EC2 instance, if it needs anything from internet, it can request. The internet can respond. I'm talking about the EC2 instance in the public subnet through internet gateway. So what I'm trying to replicate is the EC2 instance in the public subnet accessing to the internet through internet gateway. So EC2, internet gateway, internet, which is in the public subnet. Same, the EC2 instance trying to access the internet through internet gateway, which is in the public subnet. Okay. Now, the same EC2 instance can get a request from internet. So in the first scenario, the EC2 instance can request something and internet will respond. In the second scenario, the internet is requesting and the instance can respond. These are two different things. In the first scenario, instance is requesting. In the second scenario, internet is requesting. These are two different things. It's not same. It's like I'm asking you a question and you're asking me a question. They are two different things, right? Now, let's try to do the same for the EC2 instances which are in the private subnet through NAT. Now I have an EC2 instance and then internet. Now, because the EC2 instance is in the private subnet, probably it is having a database also. If instance need to update or upgrade, it will request the internet through NAT, and the NAT will respond with whatever the request which the instance made. Okay. Now from the internet, no one can make a request to the EC2 instance through NAT. Okay. The request from internet will not reach the EC2 instance through NAT. NAT will not allow that. If the database in the EC2 instance, whenever it needs an internet, it can request it, it will get the response through NAT. But no one from internet can make a request to the database server through NAT. NAT will not allow that. Whereas internet gateway will allow that as well. Okay. So if the EC2 instance wants something, yes, the EC2 instance can go to internet through NAT. But no one from outside cannot reach the EC2 instance through NAT. NAT will not allow the other way around. So the request cannot be initiated from internet to the database server or to the public private subnet instances. So even though we have NAT, the EC2 instance is still secure, isn't it? What do you think?
So it will act like a valve that it can only request outside, but no request can come inside. And may I know the reason that why anyone from outside cannot request inside this?
So it's a DB layer, maybe security.
It is security. I also know अभी दिख रहा है मुझे भी security है इसलिए ही हो रहा है. But reason क्या है मतलब वो एड्रेस रीच क्यों नहीं कर पाएगा कोई व्यक्ति बाहर से, कोई कॉल क्यों नहीं हो पाएगी?
For security reasons only, as she said. NAT is designed for that particular scenario, not to reach. If it is allowing, there will be no difference between NAT and internet gateway.
And can it be reciprocate?
No.
So what is the basic difference in net and internet? We are only told
So
about it cannot
what is
be.
the difference between NAT and internet gateway now? Can someone tell me?
Internet gateway can even request EC2 instance, but in NAT that is not possible. Only one way is possible.
How it is not possible? I just want to know this.
If you take our first lab, for the first instance, we updated our database. We installed Apache. So that we can do only if we can reach internet. Through internet gateway we did. Okay. This is one scenario when we will request to internet. Now, when we access to the internet, to access my Apache, I installed it and I'm accessing from web browser, from my internet, from my local machine, a browser I used to access I made a request and instance responded with Apache default page. Now, in our scenario, in the next scenario, we have a database. Now, if I need to update or upgrade, I can make a request and I can get a response. Okay. But no one from internet cannot make a request to the database through NAT. NAT will not allow that.
Just
Tell me
want
the
to
questions.
know how it don't allows. See,
That is
we
how
wanted-
NAT works. Basically, that's how NAT works.
I'm revolving around the ring only and not getting inside. Is there any
There is
protocol or is
nothing
there any?
inside Akshat. Akshat, there is nothing inside. Okay.
So
NAT
this is a
functionality,
hardware only.
NAT will work in that same way where it will not allow. That's it. It will stop.
No, this is a hardware. This is a software, or what kind of thing is this? That if we implement this NAT, then what is this? As like Snowball is a drive.
It's like a software. NAT functionality is not something new in AWS. We have it in on-prem also. Okay.
Yeah.
So it is just a kind of a software which we install, which only allows from one side. It will not allow from other side. Okay. Explore it. Yeah. The best answer for you is just explore how NAT works.
Yes, yes, yes.
Mm. Now, when we say NAT, we have two types of NAT in AWS. NAT gateway, NAT instance, and NAT gateway. What is your designation, Akshat? Where do you work? Or what is your designation?
Sorry, come again, please.
What is your role and designation? I'm asking.
See, currently I'm pursuing as AWS cloud for virtual machine consultancies.
Previously?
Previously, I was a technical lead for
Okay, how many
AWS.
years of experience you have?
3 only.
3 years. You said
Uh,
3 years?
yes, lump sum.
Okay. Now, can you tell me when I click on uh, a Zoom link, how I will be here? Can you?
Will redirect to its gateway.
Sorry, come again.
Redirection.
Redirection.
For example, if you click on Zoom link, okay, it will redirect to Zoom page on Zoom site. And
How?
if you have the application,
How it works?
it is called API,
Okay.
and when it will call it, then it will redirect you to the Zoom website. You can log in as a guest, or if you have the application, then you have to log in with the application.
How it happens? I mean, internally, what happens?
Redirection. I just know only this.
As I said, so what I want you to understand here is
Mm-hmm.
how internally happens, how it works. It's irrelevant for us, right? If you want to connect through Zoom, I'll just click on it and it opens and I work on it.
Okay.
Yeah, the same way. If you try to know each and every aspect, you don't go anywhere. You sit there only. For everything, anything you explore.
Mm-hmm.
So what I suggest is don't
Mm-hmm.
waste time. Don't waste time.
Okay. So
That's my
it can
suggestion.
it
But
is
that's
not
my
our
suggestion.
concern.
What you can actually do is you
Okay.
first of all understand the whole concept.
Mm-hmm.
How it works, that's none of our business, first of all. Like, okay, so NAT will work this way. Oh, okay. So when I click on Zoom, okay, it opens and then I can work on I can go for calls.
Mm-hmm.
Till till that point, it's fine. Okay, until unless you need to create a software like NAT, then you need to understand how it actually works. If you
Okay.
want to create a network like VPC, okay, in on premises, you need to go for deep dive. So what I'm trying to see, based on the previous questions you asked, if you just need to learn each and every aspect about everything, which we usually have in the beginning of our career, okay, but we will not go anywhere. Okay, so please understand, okay, how it works, and okay, keep up, like, okay, so NAT, okay, it will allow, and it doesn't allow the other way around. Oh, fine. Now subnet is basically a part of a network. Okay, fine. Until unless you need to deep dive, then yes, you can explore about it. Otherwise, learning about it at a higher level is good enough. Is good enough.
Actually, I do ask because I'm a little bit worried about the customer or the you can say that live troubleshootings. If someone asks me, then I might not get failed. And if there is, see, I don't didn't get any good uh, ambience in job side, so I started from sales only, selling the licenses and consulting the people for cloud services. So I just came into this department in
I
this domain.
understand. I understand. So even they don't ask, see, if you explain about NAT, they don't ask internally what it happens, how it works, until unless they want it. Okay. That's what I'm saying. Whenever they ask, you can answer it. And if they ask little deep, then you can say that you can get back to that later. Okay. And then you start exploring about it. Maybe that is what they wanted. But internally, even if they ask, you can explain at a higher level. Because if they are asking, they might be asking to use it, not to understand each and every part of it. See, the reason why I'm saying this, maybe I just wanted to suggest you
Mhm.
that probably you might be wasting whole time just to explore one component forever. Okay, I don't want you to do that. So if you wanted to grow, initially you need to understand the whole thing at a higher level. Then over a period of time, that is what experience is called. Over a period of time, you anyways will learn it internally how it works and all.
Mhm.
Okay. Anyways, coming back to our topic. So when we say NAT in AWS, we have two types: NAT instance, NAT gateway. NAT instance is very much same as an EC2 instance only. It just have a NAT functionality. We'll have a NAT software installed. Whereas NAT gateway is an AWS component. AWS has a managed component which is called as NAT gateway, where few things are managed in NAT gateway. AWS will be taking care of it. When it comes to NAT instance, it's our responsibility as a customer, okay, to take care of few things. For example, the instance type. What is instance type, folks? What is the instance type for EC2? Can someone recollect? What is instance type?
Like it can be a database instance or it can be a application instance
Oh my
or
God.
type of
No,
server.
I'm talking about the instance type. What is that called? What is instance type in EC2? Instance type is a hardware configuration. We select T2 micro, right?
That is tires, tier 1, T2, T3 micro.
No. That is not tire, okay? It's a family. It's a family. T represents the family, not tire. So
T.
instance type is a hardware configuration. Okay. Now let's assume I have hundreds of instances here in the private subnet. And for the NAT, I have T2 micro as an instance type. Small one, one vCPU. I'll get only one vCPU if I go for T2 micro. Now, if hundreds of instances can make a request to the internet, need to make a request, it has to go through NAT only. Now, if I have a small processor, do you think these requests can be handled by this NAT instance? No. So according to the number of requests, you need to make sure you have a right instance type. So it's our responsibility. If it's a customer responsibility to take care of the instance type. Whereas in NAT gateway, it is managed. Means according to the number of requests coming from the private subnet, the NAT gateway could expand itself and shrink back automatically. It's managed by AWS. It's a managed component. Okay. Next thing is the security group. Now the EC2 in the private subnet is making a request to internet through NAT gateway. So NAT security group should allow all traffic, then only it can reach the internet. So we should be taking care of the security group. Whereas again here it is managed. AWS will be taking care of it. And the IP addresses, we discuss about the public, private, elastic IP addresses. Okay. For an EC2 instance, we can have a public IP address. It is not mandated, but we can still have a elastic IP address if we want it. But it's not mandated. Because when you launch an EC2 instance, we can get a public IP address and we can work with it. But NAT gateway demands an elastic IP address. You have to have an elastic IP address for the NAT gateway to work. Yeah. And the last thing is the source and destination check. The source and destination check should be disabled. For the NAT instance where it is managed in the NAT gateway. Now let's understand what is source and destination check. If we, let's assume I want to connect to an EC2 instance from my local machine. Ideally, when I am making a connection request to the EC2 instance through SSH protocol, for example, okay, when I'm making a connection request, if you see in terms of this local machine, the local machine is a source. The EC2 instance is a destination, isn't it? Because it is initiating a request from here. Now, when the instance is responding, when it is responding, now the instance is a source. The local machine is a destination. Yeah. So the EC2 instance is either the source or the destination. While it is getting, it becomes a destination. While it is responding, it becomes a source, isn't it? So the EC2 is either the source or the destination. Now, by default, for all the EC2 instances which we create, we'll have the source and destination check as enabled. Means the EC2 instance will assume that is either the source or the destination. That is how, whenever we are making a request, the EC2 will assume that it is responsible for responding it, and then it will respond with some relevant response. Okay. But if we go for NAT, when EC2 instance is making a request, The EC2 instance is the source. Does NAT is a destination? No, the internet is a destination. When internet is responding, the internet is the source and for EC2 instance is a destination. Does NAT is a source? No, it is just a translator. It's like a proxy. Through NAT, the request and response are actually being made. So the NAT is neither the source nor the destination. So because by default for all the EC2 instances, it is enabled, we have to explicitly disable it when you're going for NAT instance. Otherwise, if we don't disable it, the NAT instance will assume it is responsible for responding it for the request. The NAT will try to respond. It has nothing to respond. The request will drop here itself. It will not forward it. Now, if we disable it, then yes, the request will be forwarded to the internet. So when you are going for NAT instance, we have to manage few things. NAT gateway, we just have to create an elastic IP address and then AWS will be taking care of it. Now tell me, if I am having hundreds of subnets, thousands of instances, okay, and there is a lot of traffic which is going in and out, which one is good to use, NAT instance or NAT gateway? Usually.
Instance.
Hello? Any other answers? So when there are thousands of instances which are making requests here and there, okay. Now when we go for NAT instance, we are responsible for the instance type, for example. Okay, what if that instance fails? What if the requirement changes? There are more requests coming from the private subnet instances. Then we have to adjust that NAT instance type every time, isn't it? Now, when you are creating an architecture, okay, where there is a lot of traffic going on and you don't need any downtime, going for NAT instance will become a bottleneck, isn't it? Because it has to manually be managed. But when we say NAT gateway, it expands and shrink back automatically, right? Now, if you're going for high available applications, NAT instance will become a bottleneck for us because it has to be managed manually. Whereas NAT gateway, it is managed by AWS. Okay, so if you're going for critical applications, NAT gateway is the best way to use it, not NAT instance. But for POCs, for small kind of applications where you can still manage the downtime, you can go for NAT instance. Okay, because we are going for elastic IP address for the NAT gateway, this AWS will cost us for using the NAT gateway. We can manage this NAT instance under free tier. Yes, till some extent, yes. For POCs, we can manage it. So this is how we can make an application highly available. Yeah, I mean using NAT gateway. And ideally, if you want to create an deploy an application database in a VPC, this is how you create an architecture. And in reality, you will have multiple public subnets, multiple private subnets in different availability zones for high availability as well. Okay. So when we create a VPC is created in a region. But when we create a subnet is created in an availability zone. Subnet is AZ specific. Any questions, please?
Can you let me know, like, in what scenarios we use NAT instance and gateway? I know it's a highly available gateway, but
As
in
said, critical applications, you go for NAT gateway. For
Mhm.
POCs, as I said, for NAT instance.
Okay.
Just a
If
little
you can
question.
manage manually, NAT instance is fine. But again, if you're managing manually, that means there is a chance of downtime. Sometime because before you manage, uh, while you're managing, the instance is not available. So you may face downtime. If it is okay for our applications, that's fine. You can use NAT instance. But if it has to be automated, you don't want manually to adjust because you have like a great architecture. And then if you are sitting and manually managing the NAT instance, this becomes a bottleneck, isn't it? This can become an issue in the whole architecture. So to avoid that, we use NAT gateway.
So can I say gateway is not AZ specific?
It is ASIC specific.
Gateway.
Yes. We create in a subnet. So subnet will be in an availability zone.
Okay.
I'm talking about the availability for the from our side. See,
Mhm.
when it comes to instance type, NAT gateway doesn't need any instance type. It automatically expands. Does NAT instance can be done like that? No. If I
No.
give a particular capacity, if you have a laptop, it has a particular capacity, it cannot be increased any further until unless you modify it at a hardware level manually. And for that, it needs a downtime. But NAT gateway is not like it. It expands automatically. So when we create multiple public subnets, you can create multiple NAT gateways in different availability zones. That availability is fine. But when it comes to the small aspect of increasing the capacity, NAT gateway is better, no, when compared to NAT instance.
Okay.
When the demand is varying, you want something which automatically expands and shrinks.
Mhm.
Makes sense,
Yep.
convinced.
Yes.
Okay, cool. Shall we implement this in the console first of all before we go to the next part?
Just wanted to ask a question on this Elastic IP and public IP.
Mm.
So, if we are managing it manually with NAT instance and NAT gateway is some implementation thing. So, which IP shall we fastest for this? If we have a very much of traffic on sites. But is it something like dependent? Do you have
What is
dependency
the
on
difference between public and elastic IP address, Akshat? What is public and elastic IP address? Can you tell me?
See if it is if it comes under 0000 to 65,000 something, and from outside someone can scroll our website with that IP, that is public IP.
Elastic?
With Elastic, I have confusion. That is why I asked you this question.
Guys, what
Is
is the
there any?
difference between elastic IP address and public IP address, which we covered in EC2 slides? Anyone remember what is the difference between public and elastic IP address?
Elastic can shrink when it is not used.
Mm-hmm. Revision. Anyone else? Yes, Anjali, you want to try, ma? I would be happy if you could answer. Anyone? Anyone?
Elastic is static IP address designed
Ah,
for
thank you so much.
yeah.
The difference between public and elastic is very simple. Public is dynamic, elastic IP address is static. So in AWS, when you create an elastic IP address, it will not leave your account until unless you release it. It would be there. It creates an IP address when you go for Elastic. Elastic IP address is also public IP address only, but it's a dedicated one. So when you create an Elastic IP address, that Elastic IP address will not change or will not leave your AWS account unless you explicitly release it. Okay, whereas public IP address is dynamic. When you stop and start, the IP address will refresh for the instant. So you can go for Elastic IP address for the instance also, even if you stop it, if you don't want to change the IP address. Okay. Now, knowing public and Elastic IP address, now ask your question, Akshat.
Yes. So in NAT gateway, as you told that if we have some critical applications, then NAT gateway is preferable more than NAT instance. So if we compare this instance and gateway on the behalf of public IP and Elastic IP, so if
Uh,
I am getting detached from network, then the IP will be changed, and I have to manage that myself only. That is why we are not using NAT instance. Am I right?
no. I didn't say explicitly for that. I took an example of instance type, not the IP address, isn't it? I
Yes.
never said that.
Okay.
So
So
we are using NAT gateway over NAT instance because NAT instance has to be managed, like few things. Whereas NAT gateway, nothing. You just have to create an Elastic IP address when you're creating a NAT gateway, and these things will be managed by NAT gateway.
clear, clear.
Hmm. Yeah. Now let's try to implement this in the console. So the concept, see guys, each and every one of classes of mine has to be, you need to go through the recording for the second time at least. Yeah. And for the VPC, it's a mandate. If you're not making any notes while I'm taking the class, okay. For explicitly for VPC, I wanted to do a second visit. Okay. So maybe second time you understand. I mean, now you're understanding it, but maybe you might have kind of slight confusion, and it's very common. You're not something new. Okay. So go to the recording one more time to standardize your understanding. Okay. So creation of these components is simple basically. Both, MD, both. NAT cost, yes. Because you're using Elastic IP address, AWS will cost you by default, and the request also. So let's try to implement this in the console. In AWS, in North Virginia region, we'll create a VPC with these components. So in AWS account in North Virginia region, let's go to VPC. By default, you will have a VPC created in each and every region. That VPC is called default VPC. Okay. Now we are not touching the default VPC components. Please don't touch these VPC components because see, today we are talking about the VPC. So we will create a custom VPC and then we will go for cleanup. But going forward, the other hands-on will be done on default VPC only. Now, if you have done some changes, your lab may not work. Okay. So let me create a custom VPC. I'm just giving a tag custom VPC. Define a CIDR 10.0.0.0/16. We can go for IPv6 also, but we're not doing it now. And we can just create it. That's simple. Give a name, give a CIDR, create it. Creation is very simple. So in VPC, we are giving a name and giving a CIDR. Now, after creating a VPC, we have to have subnet. Let's create two subnets, public and private, with respective CIDRs. So same, you'll have all the components here only. Go to subnets, create subnet, select the VPC which we created and give a name. Public subnet. Sorry. I'll select one availability zone. In this VPC, I will give a CIDR. Okay. Now create another subnet. Private subnet. In another availability zone, you can have the same availability zone also, not a problem. I'm just randomly choosing this in 1A, another subnet in 1B. Okay. With CIDR 10.0.2.0 /24. Create it. So I'm just creating two subnets. Okay. Public and private. And each subnet will have 256. Out of 256, 5 will be reserved, where you can use only 251. Okay. Now, once we create subnets, we can go for route tables. So let me create two route tables. Go to route tables, create a route table. First one I'll call it as public route table, custom VPC, create it. Just creating now. Go for another route table. I'll call it as private route table. Select the VPC, create it. Now we created two route tables. Now let's do this association parts. Association part. Okay. Now, first of all, I'll go to public route table and I will add the internet gateway as a route, this part. The second step is associating this subnet under the public route table. Second step. So first step is adding this as a route, adding internet gateway as a route. Second step is associating the subnet under this route table. So go to public route table, routes, edit routes, and add an internet gateway. Okay. So here we haven't created internet gateway, right? So now what we will do, first of all, we will create an internet gateway and we'll come back to this. So go to internet gateway, create internet gateway. So I would name it as custom internet gateway. Click on it. Okay. Now we just created it, but we haven't attached it to any VPC. See? So let's attach it. Or here also you can click on it. And click on the VPC, attach it. Yeah. Now go to route tables again. Go to public route table, routes, edit routes, and internet gateway, and select it. Now destination is internet. The destination is internet. Yeah. So save it. Now we did the first step, adding internet gateway as a route. Now associating the subnet. This is how we route it basically. This is how we create an architecture and we attach the components. So edit the subnet association, select the public subnet, save it. Okay. Now we did for the public route table. Now select the private route table. Because we don't have NAT yet, we will just associate this private subnet for now. Once we create a NAT, then we will see of routing it. We will not be doing this now. Okay. Now I will just select the private route table and I will associate this subnet. So go to private route table, go to subnet associations, edit subnet associations, select the private subnet, save it. Okay. So for public route table, you have public subnet. For private route table, you have private sub. Perfect. Okay. See, components, you see, it took just 5 minutes to create all these components. Now, my VP setup is almost done. Now, before I launch the EC2 instances, I wanted to automate one thing, which is in the subnets. I'll select the public subnet, Go to actions, edit subnet settings, enable auto assign public IPv4 address, and save it. Now what it will do, whenever I launch an EC2 instance, it automatically assign a public IP address to the EC2 instance. So auto assign public IP address setting is that. So whenever I launch an EC2 instance, in this subnet, I did for public subnet only, right? So in this subnet, when I launch an EC2 instance, it automatically assigns a public IP address to that instance. Okay. So now I would launch two EC2 instances in two different subnets in custom VPC. Yeah. So let me launch two instances. So go to instances, launch an instance. For public, for the instance in the public subnet, I call it as public instance. Ubuntu 20.04 LTS filter, T2 micro filter eligible. I will choose a key pair. I'll choose an existing key pair, naming it as public. So for public instance, and my just key pair name is public. Okay, my key pair name is public. And in the VPC, in the network settings, now by default, whatever the instances which we launched so far are launched in default VPC. Now let's create a custom, select a custom VPC. And in the custom VPC, we have two subnets, public and private. For the public subnet, auto assign public IP address is enabled. You remember I enabled at the subnet level. For the private subnet, I haven't enabled it. So first of all, I will launch an instance in public subnet. I'll stick with the default security group, which is already been creating with this instance. I'll stick with the default volume, basically the root volume, and I can simply launch my instance. I think we're good. Okay.
So I have a question here. So in instances, we can change assigning IP, right? Instead of subnet settings, we can choose it from instance network settings, right?
Ashish, don't do with me. Don't do with me. Yes, we can do it. Okay. You will not learn anything, Ashish.
No,
Answering your question.
I'm not doing anything. I can see that there are two options. Even we can
I'll
do
show
it.
you. I'll show you. Yes. I'll show you that. We can actually do it at the instance level also or subnet level also. Okay, but if I'm creating 10 instances in this subnet, I need to do it for all 10 instances 10 times. Correct? Manually enable. If I miss, it's gone. I need to again terminate the instance and create again. But if I do at the subnet level, it's an automation for all the instances. But yes, answering your question, yes, we can manually also enable, disable for the instances. Clear,
Okay.
Ashish?
Yes, thank you.
Yeah. So let me create another EC2 instance in the private subnet. I'm naming it as private instance, Ubuntu, FreeTier eligible 1, T2 micro. And for this instance, I'll go for key pair name as private. And in the network settings, I'll go for the custom VPC, this time the private subnet. Okay. Now, yes, as you said, Ashish, if you want explicitly, I can enable also, not a problem. I can manually enable and disable, overriding my subnet setting. Okay.
Yeah.
Now for the private instance, for the private instance, I don't need a public IP address, so I'm not enabling it. I'll go with the security group, which is already created with SSH protocol. I need SSH protocol, and I'll stick with root volume. I don't need any data volumes, and I can simply launch the second instance. Now, if you could see, I have two instances. Before I do anything, let me show you a few things. If I select the public instance, I have a public IP address. If I select the private instance, I don't need a public IP address, so I didn't create it. Okay. Now again, if I select the public instance, you see the private IP address of it. It is having 10.0.1.135. Okay, if you remember, I said that all the instances in this subnet will start with 10.0.1 because it is /24, 8 bits, 24 bits. Okay, so out of 0 to 255, there are 5 reserved. Okay, now out of 251, it took one IP address randomly, 135. So we don't have control in selecting the IP address for the instance. Okay, AWS automatically does that from DHCP pool.
I just want to ask one question.
Mm.
As there are limited and reserved IP address globally, I hope. So, wouldn't it be a fighting scenario for everyone that I want to get this IP address and I want this address? So, how do they justify or how do they provide IP address to each and every one who requires IP address? So, is it like if somebody is opting for it, then we do have each individual has these options of 65,000 IP addresses, or these are only selected as like domain names. Like if domain name is google.com, then no one can get it. So is it like that, or anyone
No.
can get any IP
These
address?
are private ranges. I can create with this range 10 VPCs with this range. Okay, you can also create the VPC with the same range because it's a private network. It's like this. I have 10 classes in a school, and each class have roll numbers 1 to 30. Now each class will have 1 to 30. They will not overlap because they are within that class only. Privately within that class, applicable only for that class. Now I can create this network with using the CIDR in multiple VPCs. I can create multiple VPCs with the same CIDR because these are the private ranges. But when it comes to public IP addresses, they should be unique
So they are limited.
because public is something where you access from internet. So you cannot have duplicate public IP addresses. You usually will not have it also.
Okay.
That's again, see, it takes a lot of time to explain about the public and private, how do we differentiate and all. If time permits, maybe in future, in the next week or so, I will try to explain it. Now, if I click on public instance, you see the private IP address, it's starting with 10.0.1. If I select the private instance, it's starting with 10.0.2 and it took 241 randomly. So all the instance in the private subnet will start with 10.0.2. So, I mean, while after launching an instance also, you can cross check whether you created correctly or not by seeing the private IP addresses. Clear? Clear so far?
Anupama, just a request. Can you just add up a step number here on this diagram?
What is that, ma?
Can you just add a step number here? The way like you have done last time would be helpful for us to take a note. So first, what we are creating and all. Just add up a number here.
Sure. Okay, one sec. First of all, we'll create a VPC in AWS in North Virginia region. Okay, so anyways, you'll be in AWS account. So in a region, you create a VPC. In a VPC, we create 2 subnets. One is public subnet, and the one is private subnet. Okay, and then we create an internet gateway. We create 2 route tables: public route table, private route table. Okay, and then we do this association. You want me to write steps here also?
That would be great.
Okay, so we will add this internet gateway as a route in the route table. We'll associate this subnet under this route table, and we will associate this one also, the private subnet, under this route table. Okay, and then we will launch 2 instances. One is public instance, Another one is private instance. Okay.
One more question.
Yeah.
How are we going to just relate it as, for example, we are learning all these things to make some clients infrastructure good, or if somebody asks us that want to create VPC and want to host an application over that, so how to manage the access from clients and to our services. I just want to know only uh, uh, a process. I don't want detailed things. I just want to know that how to set up that.
Set up which one, Akshat?
Like I am the client, okay, and you are from AWS, and I am asking you. I just want to host an application. I want to sell laptops, okay, and I want to host an application over your EC2 instance over VPC. Am I right?
Mm,
If somebody comes like that, okay.
mm,
So,
mm.
what are the initial steps we should do? We require the client's AWS account, or we will do some questionnaire with that? I just want to know the setup, how to.
So then you ask to the client whether you have an AWS account or do you want us to create. Okay. So we create an AWS account.
Mhm,
If they don't have it, then we will try to create a network. And again, it will have a lot of permissions, Akshat. So here we will use the IAM to restrict the access to the root account.
mhm,
We will talk about IAM later. But yes, IAM will be involved. And then you give only specific permissions to that particular account,
mhm,
and then you start creating a VPC. You will have an architect, solutions architect, who would be working in that project, and
okay.
architect would be creating the architecture like this, depending upon whether the user is need an application or it has a database or it's just a simple website. Based
Mhm,
on the requirement, he create an architecture, creating subnets, internet gateways, route tables, everything. And
mhm,
then they will be deploying the application. Then to develop an application, there will be a developer. If
mhm,
the user is already having an application, we take that application, but we will interact. See, if a client is already having an application, the client side, they'll have developers, right? So
okay.
you interact with the developers, you tell them how to deploy it as an architect, or you will hire a developer from your end, and then you interact with developers would interact with each other to take the code and then deploy it on the instance. And then there will be maybe the architect, or there will be another team who would be managing it, maintaining it,
Okay.
the
So,
application.
this scenario comes for if somebody want to deploy their application on cloud, but if it comes for on premises, then the architecture would be same for on premises also.
Architect will be there, but not an AWS architect, maybe
Yeah.
the one who mm,
As per my knowledge, if see on premises are things all on the things which are on premises, okay, are the same which somebody finds on cloud. Okay. Just cloud is there for safety, security, and just to manage their services. So, as per my knowledge, if somebody is looking for some uh, hardware or something on cloud, he just want to resemble all the things same like he is doing or he is having on
depends.
his
It
on
depends.
premises.
No. Yes, it can be done like that. It is called lift and shift. Okay, whatever you have it in on premises, you try to create exactly in the cloud, because when we say server, we say EC2. Okay, when we say a file system, we say EFS. I mean, I'm just trying to talk about the services which we already covered.
Yes,
Now
yes.
you can explicitly use the same services in AWS, like a lift
Mhm.
and shift, or you can use managed services. For example, instead of going for a server and then having a NAT functionality, go for NAT gateway. NAT gateway is not there in on-premises, correct?
Yes,
It's an AWS managed component.
yes.
So in AWS, there are a lot of managed services. Means You don't need to manage the server underlying. You just
Mhm.
manage the application on top of it. That's it. PaaS services. Okay. So there are few services like that. So if the customer, again, there are many ways to migrate. One is lift and shift, as I said. And another way is this one. So where you use AWS managed services, where to reduce the overhead, managing overhead.
Okay, but it would cost a lot, na? I hope.
It is not about cost, it's about the convenience. It's not about cost. See, ultimately, AWS says managed services are of less cost when compared you managing a service. So
It is that thing, na?
if the client don't want to completely manage, leave it to AWS to manage the service because of various reasons, like a vendor lock-in or see, if AWS is managing the underlying service, you don't have any control over the operating system which AWS is using it because it is taken care by AWS. So if
Yes.
you want to leave it to AWS, that's fine. But again, you don't want to give it to AWS. It's all convenience. Then yeah, customer will take care of it just
So
by using
again,
EC2 instances.
it is not our responsibility to map something or to take controls from client or to do anything. We just have to do our work only, which is like we have to create PC and we have to hand it over to the customer or to the next team.
We only manage it. We don't edit them. We just give access to the application. That's it. We manage the whole infrastructure, isn't it?
And is there any CLI included in this managing VPC, or we just have to do this only on this GUI panel?
No, see, we can access AWS services in how many ways, Akshat?
Multiple of is
Folks,
like
how many ways we can access AWS services? You remember how many ways we can access AWS services?
Console and CLI.
Mm-hmm.
CLI is console only. I hope.
And SDK.
Exactly, SDKs. We can access AWS service in 3 ways. I mean, I don't know. I feel bad if if a topic is already covered and if you are still asking on that. I mean, if you could remember the previous session's information, then yes, you can make better questions. Okay.
चलो
So
भाई मैं थोड़ा काम कर लेता हूँ, ठीक है?
we can access AWS services in 3 different ways through GUI, CLI, SDKs. Okay. GUI is something where we use it when you are learning for the first time, initially experimenting with AWS, because using CLI you may not understand what is this command, what is doing, etc.
Yes, yes.
So that's where GUI will come into picture first of all, initially.
Mhm.
And then people move to CLI because that's an easy way to do it. It's convenience. And SDKs is if they're into programming language and if you need to manage the infrastructure, then they use a programming language like Python or .NET or Java to manage the AWS services. And whether we use SDKs or CLI depends upon okay in which kind of project you are in. Because there are millions of customers for AWS, not all millions are using the same set of service in the same way. No, they access in different ways. So there will be different scenarios. Now, until as you are in a specific project, you don't know in which way you are using it. Make sense? Hmm? So now what we will do, so I have taken a screenshot and I have kept the numbers. Okay. Now I need to remove it from here because I need to explain some more thing here. Okay. I'll share that screenshot in the WhatsApp group. You are there in the WhatsApp? Yes, ma'am.
Yeah, yeah.
Okay.
I've
I'll
already
keep that
taken
in
a
the
screen.
I'll keep it in the WhatsApp group. Okay.
Yeah.
So now Now that we created the EC2 instances, created the VPC components except NAT, we did everything. We created all the components, right? Now, what we will do, we'll connect to these instances. Now tell me, if you need to connect, like till yesterday, if you need to connect to an EC2 instance, what is required? Till yesterday, I mean, if
your
public IP address,
your key and public IP.
Key and public IP address. So you have to have the PEM file of the instance, and then you have to have the public IP address. Now tell me, folks, from your local machine, will you be able to connect to this instance or not? With whatever the setup we did.
Yes.
Hello, you there? From my local machine, will I be able to connect to this instance or not? From internet.
Yes.
See, we explained this, right? Sorry. Yeah. So I can connect to this EC2 instance from my local machine. Now, will I be able to connect to the private instance from my local machine? Will I be able to? To the private instance.
No.
Right? And that is why we require that NAT you said, right?
Okay, if I have NAT, will I be able to connect from my local machine to the private instance?
No.
Then, so even if I have NAT, I cannot connect to the private instance from my local machine, isn't it? So now what we will do, from our local machine, we'll connect to the public instance. As said, we can connect it. But because the EC2 instance are in the same network, from public instance, I will connect to the private instance. Isn't it? I can connect using private IP address. So from local machine, I cannot directly access to the private instance. Definitely not. Because the setup is like that. Now what I will do, my first step is from local machine, I'll connect to the public instance. From public instance, I'll connect to the private instance. Am I clear what we are going to do?
Yes.
Now let's see how. Now, if you need to connect to an instance, I need the instance public IP address because I'm connected from my local machine from internet. I need the instance public IP address and I need the instance PEM file. I have it. I have this both. Okay. Now, if I need to connect from local machine to public instance, the public instance PEM file should be there in the local machine. Correct? Now tell me, folks, if I need to connect from public instance to private instance, the private instance PEM file should be in the public instance. But where is my PEM file? It is also in the local machine. Now what I need to do is, once I connect to the public instance, I will give permissions to this instance and I will go back to the local machine and I'll copy it. Once I copy, I will connect back to this instance. Then I should be seeing the private instance, a PEM file in the public instance. Then I can connect to public to private using the PEM file and using the private IP address. Am I clear? Hello? Or do you want me to repeat?
Clear.
I think
So,
it would be great if you repeat.
yeah, sure. Definitely. So, first of all, first step is I will connect to this instance. And I'll give permissions to this instance. Okay? And I will go back to the local machine. Means I will exit from this instance. Okay, now I'll go back to this instance and I'll copy it. So there will be a command to copy it. Now once I copy, I will connect back to this instance to check whether the PEM file is reflecting or not. Once the private instance PEM file is in the public instance, then I will connect from public instance to private instance, to this basically, to this instance. Okay. So first of all, let me connect from my local machine to the public instance. In order to do that, I have to be in a folder where I have my PEM files.
So is it like remote desktop? Sorry, RDP?
No, these are Linux instances. Who is asking
No,
this question?
no, this is Ashish. Is it similar to RDP, like we connect to a server and through server we connect to a local machines using RDP?
I don't think so. Because, see, so you're talking about this one, right?
Yes.
That is not about RDP, it's about
No,
network.
no, I'm not saying it's an RDP, but the logic or the technology is like same, right? First connect to a server which is connected through a public IP, then you
I
log
can say
in
it's a Bastion host, not RDP.
Bastion. Okay, got it.
Like a proxy.
Okay.
So let me open the Git bash here. So when I say ls, I have public PEM file, private PEM file in my local machine. Both are in my local machine only. Okay. Now let me connect to the public instance first. So take the public IP address from the instance. chmod 400 ssh-i ubuntu at the public IP address, copy it and paste it here. So ideally it should connect. Now connecting, we know, very simple, right? We did multiple times during the hands-on. So we connected it. Now I'll give permissions to a folder. So what I will do, first of all, let me elevate myself into sudo su. And even before that, I need to update, isn't it? Sudo apt-get update. Let's do this. Now, because the EC2 instance in the public having internet access, I'm able to update it. In fact, I can also ping Google from public instance. See, it is pinging. Okay. So because the EC2 instance is able to make a request to the internet, like pinging some google.com. Yeah. So now let me give permissions by elevating myself into sudo su, and I will give permissions to OPT folder. Okay. Now OPT is a predefined folder. Means like if you buy a new laptop, you will get desktop, you get documents or downloads folders predefined. It's already been created, pre-created. Right? The same way, when you say Linux, there are there are directories which are created by default with the operating system. OPT is one of the folder like that. Okay. Now what I'm doing, I'm giving a read, write, execute permissions to everyone to this OPT folder. Okay. Now if I go to OPT folder, I'll not have anything as of now. See, it's empty. When I say ls, it's empty. There is nothing to display. Okay. Now because I'm giving full permissions to user, group, or to the world, I can copy. Now I can copy this PEM file into the OPT folder of this instance. Okay. So in order to copy, I'm giving permissions at the instance level. Now I have given the permission. So how do I copy? First of all, I need to exit myself from root to Ubuntu, from Ubuntu to my local machine. Okay, now I'll copy it. So how do I copy? I would say SCP. Let me write the command first. If it is working fine, then I can explain it. So it's successfully copied, 100% copied, you see. Okay, now what I'm doing, I'm using SCP, secure copy, and I'm copying the private PEM file, private.pem file into the OPT folder by giving public instance details. Okay, so if you need to transfer some money from your bank account to your friend's bank account, if you want to copy or if you want to transfer, first of all, you have to authenticate yourself with your credentials, Then only you can copy, then only you can transfer money. Okay, so by giving the public instance details, you are authenticating yourself that you can copy it to the OPT folder of the public instance, copy this PEM file into the OPT folder of the public instance. Does this make sense? This command understood? Hello, yes.
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 Now we successfully copied the private PEM file, private instance PEM file into the public instance. Now I'm still in the local machine. Now I'll connect again and I will check this PEM file whether it is in the OPT folder or not. So how do we connect? The same command we use. Okay, I connected. Now let me go to OPT folder and say ls. You see, I have my PEM file copied successfully. See, sorry. When you are using this command, SCP command, if you see private.pem file 100%, that means it is copied successfully. You need not every time log in and check here. If it is 100% something like this here, okay, as soon as you run the command, if you are seeing something like this, that means it is copied. Now you just need to check where it is. Now it's in the OPT folder. Okay. Now I have successfully copied it. Now from my public instance, I'll connect to the private instance. This time, while connecting, I don't need a public IP address. I need the private instance private IP address. This IP address is enough for me. Okay. So what I will do? chmod 400. How do we connect to an instance? The same way. In the permissions, sh-i, the PEM file, Ubuntu at the private instance, private IP address. Now, both are Ubuntu only, both are EC2 instances only. How do I differentiate? So if I click on public instance, you see the private IP address 10.0.1.135. 10.0.1.135. Now you are in the public instance. Now, once you connect to the private instance, you would see this IP address here. Okay. So now let me connect it. So sh-i, the PEM file Ubuntu at the private IP address of the private instance. It asks, are you sure you want to connect? Yes, I would say yes. And then you see here. Now I'm in the private instance. Just before, I'm in the public instance. Now I successfully connected to the private instance. Now I am here basically. I'm in this EC2 instance. Okay. Now if I try to ping google.com, will I be able to connect? Hello?
Ideally, no.
Definitely not. Because why this EC2 instance is not able to access to the internet?
NAT is not configured.
NAT is not there. Now let's create NAT. We'll go for NAT instance because NAT gateway will charge us. We'll go for NAT instance. We will take care of all these things. We will add this NAT as a route in the route table and then we'll again ping it. Now it's not working, right? Just hanging there. Okay, I'm just Control C should stop. Okay. Now once I create a NAT and do all this, now I'll ping again, it should work. I'm just creating NAT at the right time. Okay. Now in order to create a NAT instance, launch an instance, just name it as NAT instance. Go to browse more AMIs, go to community AMIs and search for NAT. Search for NAT. Okay. And in that NATs, in that particular options which we get, select this one, Amazon one, which is a NAT one. Okay, select this. So if you scroll down, you will see Red Hat, you have this and all. You select which is starting with Amazon with the AWS logo. Okay, and it has NAT. So select this. T2 micro, I don't need a key pair. And the NAT has to be created where? In the public subnet, in the VPC. So in the VPC, in public subnet, create the NAT. Okay. Now when you're creating NAT instance, you should be taking care of instance type because I have only one instance here. The NAT instance is T2 micro is enough. Security group should have all traffic open. I have to have a public IP address. So public IP address is enabled. In the security group, I'll open all traffic. Okay. So this is done, this is done, this is done. And source and destination check will be done after launching an instance. Okay. Now I'm opening all traffic, sticking with the root volume and launch an instance. Okay. Now the instance is being created, basically launched. Now go to actions, networking, source and destination check, disable it and save it. Now, even these are all things are done. Now the only thing which is left is adding the NAT as a route in the private route table. Then only the instance can make a request through NAT to reach the internet. Okay. So go to route tables, select the private route table. My internet seems to a little slow. Go to routes, edit routes. And here we go for instance. And if you see, you will see 3 instances. You see the importance of tags. I need to select NAT instance, destination as internet, and save it. Now, if I ping it, ideally it should work. See, it's working. Just before when I pinged, it didn't work. Now, after adding a NAT, taking care of necessary things, and adding this NAT as a route in the route table, then yes, the EC2 instance is able to ping through NAT, reaching the internet. Okay, so that is the end of this particular project. It's basically a project 1. Because there are a lot of components, it can be a little complex, but implementing is easy only. Any questions, please, before I give a break to you and then you can start doing it? Any questions?
There are no questions, but there would be some confusion. So I was
Common Akshat. Don't worry about that. So as I said, I want you to visit the recording one more time, please.
Yes, sure.
Very important. Very important. Please, folks, it's very important topic in the whole, like in the certification. This is the main topic. Everything will be related with this only. Okay. So while doing the hands-on also, you will learn few things. Do it consciously, understanding each and every step. Okay. Ashish, you unmuted. You have any question?
No, I said no questions.
Okay. So before I give a break, last thing is let me show you how to go for cleanup. We may miss that at the end. So in order to delete the VPC, first of all, you need to delete the dependencies which are instances. Okay. Now you have to wait for the instances to be terminated before you delete the VPC. Now, when we talk about VPC, we created VPC, we created subnets, route tables, internet gateways. But when deleting, you need not do individually. You delete that VPC, everything will be deleted with it. Amazing, isn't it? Yeah. So, but you have to wait for the instance to be terminated. So without instance are terminating, you cannot delete a VPC. You see, unable to delete. There are instances which have been running. So these are the dependencies. Now they are terminated. Now do a refresh. Select the VPC which you created. Actions, delete. They're still depending. Okay. So previously it is not like that. Nowadays, even though they are deleted, they're terminated. Internally at the back end, there are few components which are still related. So it is throwing an error. It's still saying unable to delete. Okay, we'll do one thing. We'll go for a break. After the break, we'll try to delete it. Maybe by the time if it removes, that would be wonderful. Okay.
Sure.
That's okay. That's fine. We will see after the break. Yeah. Happy break, folks. Take a good break so you can come back and do this hands-on. Hi, is everyone back? Hello, am I audible?
Yes.
Okay, so let me try deleting now. Yeah, you see? Now it's saying that when you delete the VPC, it will delete all the components of VPC also, like um, the route tables, the internet gateway, okay, the security groups, okay. It should show the subnets also. This is one, right? Yeah, the subnets also. Okay, so it's saying that when if you delete the VPC, it deletes all the components. Yeah, now if I click on delete, it is showing deleting security groups, deleting internet gateway subnets, and then route tables, that finally VPC. Okay, so it's a good practice. Basically, if you delete the VPC, all the components will be deleted, so that you need not worry about deleting each one individually. And it also avoids touching the default VPC components. You see, now that I deleted the VPC, the one which we created, but if you see the go to subnets, you will still see the subnets. But for the default VPCs components, these are all the default VPC components. Okay, so this also avoids you to touch the other VPC components if you delete only the VPC instead of touching each and every component. Okay, so now you just go to the Google Drive and you can start working on the lab. I'll create the breakout rooms. Probably I'll create 2 rooms. Okay, so you guys can work together. And I will copy paste this screenshot in the WhatsApp group. Okay, so that you can do as per the number of steps. So please do join your rooms. Sunita, in which room you are into?
Sorry, Anupama, I just joined
After the break. No
after
problem.
the
I
yeah.
just created the breakout rooms few minutes before. I will
Okay,
add you to a room, okay? You can continue
sure.
doing it. You can
Okay.
start doing it, in fact. Yeah, good.
Hi Anupam, I got disconnected from my room. Please allow me.
Sure, sure.
Anupama, just one question. I mean, like, is it correct? Like, when in that setting is there, na change source and destination check. So, with the help of that setting, is it that way? Like, we are creating a checkpoint for. Hello.
Yeah. Please come again.
Yeah. So we have done that. Like, there is one setting called as change source / destination check.
Correct.
So that means like we are making that NAT as a checkpoint, right? We are
As
enabling
a
that
proxy.
checkpoint
We are making that as a proxy.
as a proxy. Okay.
In simple terms.
Okay.
Is everyone done?
Yes. Yes.
Guys, if you are done, you are good to leave. Please do the cleanup. Don't forget to do the cleanup.
Okay.
First of all, terminate the instances and delete the VPC.
Okay. Yeah. Thanks, Anupama.
Yeah.
So VPC will delete all the associated subnets and the.
Correct, Ashish. That's right.
So we can leave for the day, right, Anupama?
Anjali, you said something?
Yeah. Can we leave for the day?
Yes, ma. Yes. See you tomorrow.
Yeah. Thank you.
Yeah. Who are done? Guys, don't forget to do the cleanup. You are creating 3 instances. Okay?
Right.
Don't forget to do
Yeah.
the cleanup, please.
Yes.
Yeah. Terminate the instances, delete the VPs, and you're good to leave for today.
Okay, ma'am. Done.
Sujita?
Okay, see you tomorrow.
Yeah. Bye-bye. Bye, folks.
Mm.